Hey everyone, welcome back. This is class number 5 in our Algebra 1A course. Let's take a look at what's going to happen. So we're going to be isolating a variable from within an equation. Now you might be like, I already did this. It's going to be slightly different today because there's going to be multiple variables in our equations, and we're going to try and pick one of them out of the bunch and find out what it's equal to. And then we'll do that by just random equations, then also rearranging some well-known formulas as well. Questions for today: what does it mean to isolate a variable? And then what are dependent and independent variables? So what do those mean? Can you define each of those by the end of today? All right, so when we think about isolating variables, same rules apply as before. We're going to do reverse PEMDAS. So we're going to try and, I guess I want to use solve in quotation marks because we're not really solving in this case. We're rewriting an equation in terms of other variables is what we're actually doing. But one thing to note, if we have a fraction, just make sure that if you've got, say 3x plus 4 over 2, that you think of that as there being a parenthesis around the top part, so the 3x plus 4, because the whole numerator is being divided by 2. So sometimes having that parenthesis helps you see that. So if you don't see it, sometimes it's worth just kind of sketching in for yourself. The word to isolate is to have it on its own. And in our case, what we're going to try and do is get the variable that we are targeting. So we're going to be asked to target a variable. We're going to try and get that on its own on one side of an equation. So you will have variable is equal to whatever's left. So if we look at this first one, y equals 3x plus 7. There's two variables in here, x and y. The y variable is the one that is currently isolated. So on one side of the equation, there's a single y, so it has to be a single unit. So there's the coefficient in front of it is 1. So like if I move the 7 over to the left-hand side, so I subtracted 7 from both sides, the x is still not yet isolated because it would still be 3x left. So we'd have to also divide by 3 to isolate x. And then in this formula, square root of a squared plus b squared equals c. The c variable is the one that is currently isolated. And if I wanted to isolate a, I would need to get rid of the square root, the b squared, and then the square on a as well. I would need just a single coefficient of 1 to the power of 1 as well. So it's kind of important to know that coefficient is 1 and it's to the power of 1. That is when the variable has been truly isolated. So it means that on the other side, we are getting a true picture of what a single y is worth or a single c is worth in comparison to the other variables. So let's just take a look at this example. 2x plus 3y equals 7. At the moment, there's nothing to solve because with two variables, you can't just say like, oh, x is 10 and y is minus 2. Like we don't have enough information to begin solving that. So this one cannot be solved like we have been able to do with our other equations so far. So this is a two-variable equation. So we might be asked to isolate a variable. And we're going to be asked to do this a lot. There's no might about it. We're going to be asked to do this a lot. So I want you to really get comfortable with this idea. And it's going to use the exact same tools that we did with solving for a single variable. So you might get asked to give your answer in terms of. In terms of is usually going to be followed by like another variable. So up here at the top, it might be rewrite in terms of x. So find y in terms of x. So that means you're going to isolate y, you're finding y, and on the other side, there's going to be an x value, or if there's 3 variables, there might be 2 on the other side. So it's in terms of the other. So we don't know what they're worth, but here's the relationship between the two of them. All right, so if this one we're asked to find the value of x in terms of y, that means we are searching for an x equals situation. So we want to get x on its own. We're finding the value of x and there will be a y on the other side. So we've got 2x plus 3y equals 7. If I want to get x on its own, the 3y term and the 2 all need to go. Thinking of reverse PEMDAS. This is the confusing part because what we're going to actually do is take that entire term 3y and move it over to the side. So if I want x, 2 is being multiplied, 3y is being added, and addition subtraction we're going to get rid of first. So we're going to subtract 3y, the entire term, from both sides. So 3y minus 3y is 0y, and anything times 0 is 0. So on the left side, I'm left with 2x. And on the right-hand side, 7 and 3y cannot be combined. They are not the same. 7 does not have a y variable. So this is just going to stay 7 minus 3y. So when they can't be combined, you just put them in line with one another. Next part, I want to get x on its own. This is a bit more familiar now because we know how to do this. It's 2 times x. So to undo that, I need to divide by 2. And we're dividing both sides of the equation by 2. So the 7 and the minus 3y, both terms are going to get divided by 2. So 2 divided by 2 is 1. X is equal to 7 minus 3y, all to be divided by 2. So that is the value of x in terms of y. So this is what x is equal to between numbers and y's. So if a term contains a variable, so like the 3y, we treat it the exact same way as we would any other number. You can add, subtract, multiply, divide, particularly if we want to move the entire term somewhere. So we want to, so like let's say I had a weird one, like I had 3ab, and I want to get a on its own. Well, 3 and b are both multiplied, so I would divide by 3 and b on both sides of the equation. So that would cancel the 3's out and the b's out, and I would be left with just a. So it doesn't matter if like there's variables in there too. Like we're going to treat this the same way you would any number because it is a number. It represents a number. We just don't know what that number is yet. Okay, so what you may be asked to do is to rearrange some formulas. And the reason we'll do this is that a lot of formulas have what we call an independent and a dependent variable. So an independent and dependent variable. So that means that one variable changes in response to the other. So if we think about a car, usually what we would think of is the distance that we drive is equal to the speed that you're traveling at times how long you're driving, right? So the speed of the car times how long you're in the car is going to tell you how far you drive. The distance would be what we would call the the dependent variable. So this one depends on how fast you're going. So this would be independent. And then time as well would be another independent variable. So as one changes, the other is going to respond. So one of these will be like your speed is the one you're in full control of, and that will dictate how long it takes you to cover the distance. And usually we would know one of those. So it might be like you're going 2 miles down the road. You want to know how long it'll take you, and you would say, okay, well, if I drive at this speed, it'll take me a given amount of time. If I drive faster, it'll take less time. If I drive slower, it'll take more. So the distance will be fixed, and the speed and time will become the two types of variables that we're dealing with. So what you might be asked to do is like say, okay, rewrite this formula, write the value of time in terms of distance and speed. So we want to get what is time equal to from this formula. So usually if I have words like this, I like to abbreviate it. So I would say like S is equal to D over T. And I want to get time on its own. I want to get T on its own. Make note of this in your notes. This is a special scenario. If you're trying to move a variable that is underneath of a fraction like this. So I want to get T out of the fraction because if I need T equals 2 on its own, just moving D is not going to help. Like if I divide both sides by D, they'll cancel, which is great, but I would end up with an S over D equals a 1 over T, and that's not the true value of T, that's 1 over T. So that's not super helpful. So what we need to do instead is say, all right, if I want to get t on its own, I need to get it out of that denominator. The way to do that is to cancel it on the right-hand side by multiplying by that variable on both sides. So if I multiply by t on the right side, it will totally cancel. So t divided by t is 1. If I do it to the right-hand side, I must also do it to the left. So now on the left side, I have time. Sorry about that. So we have t times speed is equal to distance. So time times speed equals distance. Now I want time on its own. So what I'm going to do is say, okay, well, it's multiplied by speed. I want to divide by speed on both sides. So I'm going to divide by s on both sides. So on the left side, they cancel. I'm left with time. And then distance over speed. I know my s's look like 5s. It's an s. So that means, going back to my words, time equals distance over speed, and which makes sense. If you're trying to figure out how long is it going to take me to get somewhere, you would say, okay, well, how far are you going? How fast are you going? If we divide those two, we're going to get our time. You're going to be asked to do these sorts of things, rearrange formulas to find the value of a given variable in terms of the other ones. All right, here's another one. Very common one. The total cost of a purchase is going to be the price times the number of units you bought. So we're going to rewrite this one to show price in terms of the total cost and the number of units. So I'm going to say C equals price times number of units n. So I'm picking random variables. So I'm just making it up. I'm just saying C, P, and N. I want to get price on its own. So to do that, the number of units would need to go. They're multiplied, so I'm going to divide by n on both sides. So that means C over n is equal to P. And putting back words, total cost divided by number of units would be equal to the price. And that would be price per unit, so price for a single unit. So it's something like you bought 10 candy bars for $10 and you want to find out the price of a single one. Well, you would divide your $10 by 10 candy bars and that'll tell you the price of one candy bar. So some of these will be very much like, oh yeah, that's common sense, I get that, that's fine. And some will be a little bit harder, and we'll look at some harder ones now. So for this one, straightforward, just examples and rewrite. Attempt to isolate the desired variable in the given formula. Now I know technically the first one we're not doing a variable, this is pi, but I always think it's kind of interesting to see what pi is actually equal to. So C equals pi d. This is the formula for the circumference of a circle. So pi times the diameter. Pi is an irrational number, remember? So it's not a variable. We actually know the value of pi, but it's irrational, so it has no definite ending, and it cannot be expressed as a fraction a over b. So it can't be done. The value of pi, so if we want to get it on its own, we would say, okay, C equals pi times d. I want to get pi on its own. I would need to divide by d on both sides. So that's the diameter of a circle. So C over d, circumference divided by diameter, is equal to pi. So if you want to find the true value of pi, you take the distance around a circle, its circumference, so distance around, divided by the longest distance across the diameter, and that will give you pi. All right, second one, P is equal to 2L plus 2W, so that's perimeter is equal to 2 times the length plus 2 times the width. Write the equation to find the value of L. So we would say, okay, P is equal to 2L plus 2W. We want to get L on its own. So first thing, reverse PEMDAS, L is being multiplied by 2, and then we're adding 2W to it. So addition subtraction goes first. We're going to subtract 2W from both sides. So I know this is kind of the one that's going to be like, ooh, I didn't realize I could do that, take a whole term away. But 2w minus 2w is 0. So we're left with p. You can't subtract 2w from it. Those are different variables. So p minus 2w is equal to 2l. And then to get L on its own, we need to divide both sides by 2. So you can, and I don't know if you guys knew this or not, you can separate this. So P minus 2W divided by 2 is the same as P over 2 minus 2W over 2. That's all equal to L. So you can actually separate it or you can keep it the same. It doesn't matter to me which one you do. So like if you told me this P minus 2W over 2 is the answer, I would say, yep, you're absolutely right. And if you told me, 2's would cancel here, so if you told me P over 2 minus W is equal to L, I would say also absolutely true. So the perimeter divided by 2 minus the width would be the length. And then last one down here, a squared plus b squared equals c squared. Find the value of b. So we want to get b. It's being squared, so we're going to have to get rid of that square part at some point, but it's also having an a squared added to it. So we want to subtract that a squared from both sides of the equation. So they will cancel over here. B squared is equal to c squared minus a squared. Now this one may be new for you, but to undo squaring something, so b squared, so that means b times itself, it wouldn't be to divide by b. So that technically would get rid of the square part, because b squared, I don't know if you guys know this, b squared is b times b. So if I divide it by b, they would cancel, I'd be left with just 1. But that means that I would also have a b over here on the right-hand side, which now doesn't work because it's not, I'm not going to get just b equals. There's another b hanging out there somewhere, which is not acceptable. So we need to do something else. The opposite of squaring something is to square root it. So that is the inverse operation. So the thing that will undo squaring is to square root, and you have to square root both sides of the equation. So the square root of b squared, square root and the square cancel. So I'm going to be left with b is equal to the square root of c squared minus a squared. You can't cancel the squares for c and a because they are subtracted. So they're not separate. So it's the square root of whatever their difference is, and we don't know what that is yet. So we can't do anything else with this. So we're done at this point. So b is equal to the square root of c squared minus a squared. All right, it's your turn. Pause the video, take a shot at it, come back and see what the answers are. All right, so first one, a equals 4b minus 5. Rewrite the equation to find the value of b. So this would be maybe an area and a base formula. So we want to get b in its own. Solving for b, we've got to get rid of the 4 and the minus 5. The minus 5 is subtracted, so that's going to come first in our reverse PEMDAS. We're going to add 5 to both sides of the equation. A and 5 are not like terms, so you can't combine them in any way, so we're going to write that as a plus 5 is equal to 4b. Getting b in its own, 4 is multiplied by b, so the opposite of that would be to divide. And then 4 divided by 4 is 1, so my final solution is a plus 5 all over 4 is equal to b. So I've isolated b. b is now on its own. Second one, v is equal to pi r squared h. This is the formula for the volume of a cylinder. So we want to find h on its own. h stands for height. So if I want to get h on its own, even though we see like pi and r squared in here, it's actually not that bad. We don't have to do any like square roots here because we want to just get h on its own. These are all being multiplied. So it's pi times r squared times h. So to undo that, we need to divide. So if I divide by pi, the pi's will cancel. And if I divide by r squared, so I can divide by that whole variable squared, it'll just cancel out. So pi's will cancel, r squareds will cancel. And I just have to do the same on the other side, pi and then r squared. So my final solution would be v over pi r squared is equal to h. All right, and the last one, we've got V equals 1/3 B times H. This is the volume of a pyramid. So volume of a pyramid is 1/3 of the base area times the height. So base area can be broken up depending on what the shape is. So if it's a square, then it would be like a side length squared. If it was a rectangle, you would do like a length times width. If it was a circle, it would now be a cone, but you kind of get the idea. So it's whatever the base area is. So we want to find the base area. We want to isolate the base area. So we've got 1/3 base area times, I just wrote times using a star here just to kind of make sure that we got that it was different. So the 1/3 and the H are both being multiplied by the base. So to undo that, I think it might be easier to do this one at a time. So rather than like trying to divide by 1/3, which is a little more complicated, let's just divide by H first. So you can always do it in steps. Like just up here in question 2, we could have also just done divide by pi, rewrite it, and then divide by r squared. It would have worked out just fine. So they cancel. So down here we've got V over H is equal to 1/3 B. Now it's kind of easier to visualize how to get rid of this. 1/3 times B, so it's multiplying by 1, dividing by 3. If we multiply by 3 and divide by 1, 3 divided by 3 will cancel, 1s will cancel, but we have to do the same thing over here, 3 over 1. So then with fractions, remember, you multiply the numerators together and you multiply the denominators together. So we're going to get 3V over 1H, or just H, is equal to B. So 3 times the volume divided by the height would be equal to the base. If you have any questions about those, maybe rewind it, watch back again, see if it makes more sense. If not, make sure you're bringing those questions into class, Knight's Quest, or tutoring. All right, your turn. You're going to practice independently now. If you're at home, you can access your online textbook. It's page 58, questions 1 through 20, and you can do any 10 of those. I also have the PDF for this posted in Schoology for you. Get cracking on that. You can choose any 10. I suggest you try some easy, some medium, and some hard ones, and they get harder the further down you go. All right, so our essential questions for today. What does it mean to isolate a variable? It means to get a variable on its own. So you are left with variable, so whatever it is, like x equals, and it's 1x to the power of 1. So it's just a single unit of x is equal to whatever's left. Dependent and independent variables, a dependent variable changes based on an independent variable. So the total cost of something will be based on the price of an individual item. So if we were saying like you're going to go in to buy something, well, the price is going to influence the total cost. So the total cost is a dependent variable upon the price. And then for tonight/today, textbook work, page 58, questions 1 through 20, you can choose any 10. So emphasis on any 10. Now that does mean that you can do all 20. Like it doesn't mean that you only have to do 10. You can do a minimum of 10, but 10 is the least I'm looking for from you, but extra practice always helps. All right, I'll see you all soon.